So we're going to go through two different problems on how to do solution stoichiometry problems. In order to do solution stoichiometry, you need to keep in mind that we're using molarity. So molarity and volume will help us convert to moles. Once we get into moles, then we just go back into our regular stoichiometric ideas. If they give us something else like grams, then you're going to have to convert to moles and then do the stoichiometry. And if the final answer wants grams, you would need to also convert back to grams at the end. All of stoichiometry occurs in a mole to mole ratio. So here we go. The first problem that we have to look at, maybe, is how many liters of 12 molar hydrochloric acid are required to completely react with 13 grams of zinc. So the first thing we would need is a balanced chemical equation. So here's that, except it's not balanced. Zinc reacts with hydrochloric acid and it makes zinc chloride and hydrogen gas. All right. So things to keep in mind. First, is the equation balanced? Well, I already gave you that little hint. It's not balanced already. But this one's pretty easy. Notice that we have one zinc on each side, right here, one zinc and one zinc. We have one H and two H's, one Cl, two Cl's. So in order to easily balance it, we just need a 2 right there. All right. Next question. What is being given to us in the problem? Well, they give us two things. 13 grams of zinc is what we're going to be reacting. And they also tell us the molarity of the hydrochloric acid solution is 12 molar. We're going to need to figure out something with that at the end. But since we're starting with zinc, we have grams of zinc right here. We're going to convert grams to moles. Then we'll know how many moles of hydrochloric acid we will need to react. And then we can use that number of moles in our molarity expression. So to know what we're solving for, it is volume in liters of hydrochloric acid. So on the next page, here we go. Here's our balanced equation. We need to do some of our stoichiometric steps. First, we take the grams of zinc that we know we're beginning with. Grams don't do us very much good. I need to convert that to moles. So I set up my little chart. 1 mole of zinc is 65.39 grams from the periodic table. That tells me that I have 0.199 moles of zinc. In the balanced equation, every 1 mole of zinc needs 2 moles of hydrochloric acid. So if I have 0.199 moles of zinc, then I'll need to multiply that by 2 moles of hydrochloric acid so that the moles of zinc will cancel, and I'll be left with the number of moles of hydrochloric acid of 0.398 moles. That is how many moles we need from a 12 moles per liter solution. Since molarity is moles per liter, and we just plug in the numbers that we know. I know that I have 12 molar. I know that I have 0.398 moles required. I do not know how many liters. So I'm going to do my algebra trick, and we just cross multiply and divide to get the unknown all by itself. It'll look like this. The number of liters is 0.398 divided by 12 molar. And when we do our math, we get 0.0332 liters. That would be the final answer. This would be in liters. If we needed that to be in milliliters, I would need to multiply that by 1,000, and the answer would have been 33.2 milliliters. All right, let's do another problem. How many milliliters, sorry about the random line, that's going to be used later. How many milliliters of 0.6 molar silver nitrate solution would be needed to completely react with 40 milliliters of a 0.1 molar aluminum chloride solution? Well, again, we need a balanced equation. This time it's pretty easy. Oh, no, it's not. I messed this one up. My math is going to be wrong. Dang it. So let's see if I fix this. Let's go back a couple slides. Okay, there is our balanced chemical equation. I messed that up before and had to go back and make a couple changes. So the aluminum chloride is going to react with silver nitrate. But to balance the equation, we needed this 3 right here, right? This little 3 was required. So for 40 milliliters of 0.1 molar, that's going to be 4 millimoles. So all I really did is I multiplied those, and the prefix milli was left behind. This is like, it's going to be a trick that's going to help us out where we don't have to go into really, really small fractions, right? So 40 times 0.1 is 4, and that is in millimoles. It is a 1 to 3 ratio, so we're going to need 3 times as much of this stuff, right? Which means 60 molar 0.6 molar is 12 millimoles over some number of milliliters. So now remember, molarity is moles per liter. So if I have millimoles and milliliters, what that really means is these two things can cancel each other out. And my answer will still be in milliliters when we get done. All right. So now to move on here, what's the next thing we need to do? Hopefully you realize that we need to rearrange this again to get milliliters by itself. So when we do, there's those being crossed out, we get 12 millimoles divided by 0.6 molar. That is going to be the number of milliliters. Again, trust me that the units work. If you're in milliliters and you're solving for milliliters, notice our answer went in milliliters, you do not need to convert all the way down back to liters and then back to milliliters again. So anyway, the final answer here would have been 20 milliliters to be able to completely react. All right. Hopefully these are starting to make a little bit more sense. You need a balanced chemical equation. You need to use the ability to convert milliliters and molarity to moles. And then the old stoichiometric ratios. What is the balanced equation telling us about what's going on? If we're trying to figure out how many grams of something is being made, once I get to the answer of moles, then I need to convert that back to grams. Hopefully this helped a little bit and it can help you finish some of the assignments that you've gotten.